This is an introduction to the washer method in calculus. As you see here, it's a lot like the disk method, which hopefully you've already learned about, but just to refresh your memory, here it is. So what you're doing with the disk is you're rotating a line or a graph around one of the axes, and you're finding the volume of the 3D shape that it makes. So to do that, you're integrating the cross sections of that shape. And anytime you revolve a graph around the axis, it creates a 3D shape with cross sections that are circles. So to find the volume of the shape, you integrate the area of a circle, which right here is pi r squared, and you can see by this formula, it shows us the method. So when you integrate pi r squared, which is the area of a circle, you can pull out the pi because it's really a constant. And what you're doing is just integrating r squared, which stands for the radius. And the thing about it is the radius, when you're using the disk method, is just the function, because it's the distance from the top of the function down to the x-axis, which is just your y value, which is f of x. And then the a and b here represent the limits of integration. So as I mentioned before, the cross-section of rotating around the axis creates a circle here. And to find the volume, you're integrating from a to b, left to right, finding the area of infinite amounts of circles between this area. And what that creates is a 3D solid right here. And the most important thing about the disk method is that the cross section is a solid disk. It's one line going around, and you're just integrating one radius. So this now brings us to the washer method, and right off the bat you'll probably notice the biggest difference here, which is you're integrating two circles. That's because in the washer method you're finding the area between two curves and rotating it around the axis to create a 3D figure. This also creates a different looking cross section. As you remember with the disk method, it was a solid disk because one function was making up the whole area. But now you have two, and you just want to find the difference between those two areas. So it creates a washer where you're finding the big area of the top function and the smaller area of the bottom function, and you're subtracting them, giving you the area of this washer. Brings us to our equation. Remember, you're integrating the difference of the area of two circles. So to do that, again, you pull pi out, and it's the difference of the radius. It's r squared of the outer function minus r squared of the inner function, which translates to f of x squared minus g of x squared with respect to x. The rules for the limits of integration are the same. It's a to b, either the question will give you a set boundary or you find where they intersect, and that's your limits of integration. In the washer method, and finding the area between them, so you have to subtract the area of the inner function from the area of the larger function. If you know the disk method well, this really kind of becomes second nature because there's not much more to it. You just have to remember to subtract the inner function, and that's pretty much it.